This question is about ketones. Solution X reacts with liquid ketones to form a crystalline solid. The reaction can be used to identify a ketone if the crystalline solid is separated, from our liquid mixture, purified by recrystallization, and the melting point determined. Describe how it is separated and purified. So we don't have to describe the melting point part. So we're separating a solid from a liquid. So our liquid reaction mixture, and we've created a solid. So we would filter the solid from the liquid mixture. And we might do that under vacuum filtration or regular gravity filtration. But then how is it purified? So how do we purify a crystalline solid? This is about recrystallization. So we dissolve in the minimum amount of hot solvent. We then filter whilst hot to remove any insoluble impurities. And then we're going to allow to cool so crystals can form. And then we're going to filter under reduced pressure. So that's Buchner filtration. We're going to wash with cold solvent to remove soluble impurities. And then dry. And then we'll be able to find its melting point. Propanone reacts with the weak acid HCN to form a hydroxynitrile. This hydroxynitrile is usually made by the reaction of propanone with KCN followed by dilute acid instead of with HCN. State the hazard associated with KCN and suggest a reason other than safety why KCN is often used. So cyanides are toxic. So that's our hazard. Why would we use KCN instead of HCN? Well, the concentration of CN minus ions is higher in KCN. KCN is ionic, HCN is covalent. Or you could say that HCN is a weak acid, it only partially dissociates. KCN is ionic, so fully dissociates. So that is why we use KCN instead. Outline the mechanism. So propanone, so it showed us the structure at the top, CH3, C double bond O, CH3. We don't put the metal in the mechanism, we're using the cyanide ion where the lone pair is on the carbon, and it has that minus charge. It's going to attack the delta plus carbon, and the double bond is going to open up. This is a nucleophilic addition that we're doing here. So the CH3s haven't done anything. We've added the CN via the C. We've broken the double bond and made it an O. We've put a lone pair onto the oxygen because we've moved electrons from the double bond onto the oxygen. They then go and get from the acid the H+.